Welcome to School of Civil Engineering. As we have started a Etabs tutorial series, and with respect to that, today we are going to discussing about that how can we assign point load, uniformly distributed load, or uniformly varying load, or joint load for different kinds of frame or different kinds of beam, or if the frame are inclined, that how will provide that load, and if we have to provide the load middle of the beam or frame, then how can we provide the load. So today we'll discuss about that. So let's start. If you cover my previous video or watch my previous video, then you know about that frame. So we have analyzed about that frame, and we have analyzed that frame, but someone comment me that if we start our load providing from that point to that point, then how we'll provide our load, or how we'll calculate the distance, relative distance or absolute distance. So to discuss that, and it is really a little bit difficult that how we'll provide. Suppose from here to here, how I'll provide a uniformly varying load. In how we'll provide uniformly varying load from that point to that point. So today we'll discuss about that. So at first we have to open our Etabs, and one thing that in this series, if you have any problem or if you need to know anything about Etabs 2016, you can mail me or comment me, and I will try to make that video for you. So first of all, we'll open from here, new model, click here, and then use user default setting, okay. And here is the main thing. We know that when we'll work for frame or beam, we'll take y grid as 1, and then we have to go our figure. Here we're seeing that in x-axis we have here 1, here 2, here 3, and here 4. I have already discussed about that in my previous video, so you can watch that. And I'm directly going to do that. First of all, 4, 10 and 2. So from here our number of grid line is 4. I'm going to edit that. I'm going that quickly because I have already discussed about that in my previous video, the link given in description. So first of all, we have to select a spacing from here, 4 feet, 10 feet and 2 feet, and in Y it's no matter how much, 4, 10, 2. Let's check again, 4, 10, 2, okay. And here the Storey height, Storey data here, from here our Storey is 1, 2, 3, 4. Consider that I have a 3 Storey and 1 base. Here to here we'll take as base, and from here to here we'll take first Storey and second Storey. So our number of Storey we'll consider 3, number of Storey 3, and topical Storey height will not give that, and bottom Storey height is from here, bottom Storey height from here, actually from this here to here 8 feet, 8 feet, and we'll go custom grid, edit, here first story. Sorry, we have to put a 3, not 2, 3 story, custom grid, edit get story, and sorry again. Okay, bottom story height 8, custom grid, edit, and then here we have to provide the value. So this is base. First of all, we have to provide 10 feet, or first of all we have to provide 8 feet, 10 feet and 5 feet. Here 8 feet, 10 feet and 8 feet, 10 feet and maybe 4 feet, sorry 5 feet. We'll delete that because it's not required for us. Delete that 8, 10, 5. Okay, that's okay. If you don't know that how to do that, you can see my previous video. And after that we have to go here, plan, select one to draw here. So from here we have to draw beam. So from here frame, and let it as default because we'll ignore that. From here to here, and then from here to here, and then from here right click. Okay, here from here to from this point to first of all this point, then this point to this point, and this point to this point we have drawn, and then we have to provide support here. Select that. Here we got a hinge support, but we have to provide here fixed support, restraint, fixed support, apply, and again select here, we'll provide here hinge support, apply. Okay, our frame are ready. Now we have to provide load here. Now we have to calculate from here. That is the main thing, that we have to calculate from here that suppose we'll provide 4 keep load here. Now how we'll calculate that distance? We'll use here only absolute distance. We'll use here only absolute distance from 0 to 5. I mean we'll provide load at 5 feet distance. So here select that frame analysis, frame load, point load, and from here we will select absolute, and when load 5, then before that we have to show our grid system. Click here, assign other object assignment. From here local axis, apply. So here are the local axis, and in my previous video I have discussed with you that we have to provide that load according to local axis, because our the direction of our load not going in X, Y or Z direction, it's going respect to that frame, and respect to that frame they have some axis. It is known as global axis. I have told you that the red is 1 and this is 2, green is 2 and the blue is 3. So if you don't understand about that axis, you can see my previous video. I think it will be clear to you. And now select assign frame load, point load. Then our load are opposite direction to global axis 2. So first of all we have to select global axis, local axis 2 and select absolute, and when distance 5, our loader at 5 feet distance, loader 4 keep. Apply. Select that, see load, dead load, apply here. You are seeing that loader in other direction, that north or direction according to our math. So this is the problem, because if we see here, this direction are showing that in left side, in our left side. So we have provided the value in plus, that's why this direction are also showing plus, cause according to this direction this value will be plus. So we have to press here -5, replace with the existing load, apply, and if we see here, refresh, or if you see the load is in that direction. Okay, now here suppose we have to provide load from this point to this point. In my previous video I have told about first of all select that, assign frame load, distributed load. Here there have two things: relative distance from int 1, absolute distance from int 1. Now the fact is, when we'll use absolute distance and when we'll use relative distance. We can use absolute distance when the frame are in according to x-axis or z-axis. Then we can use relative absolute distance easily. But when we'll use relative distance when the frame are not in x, y or z axis, when we have to follow its own axis, I mean this local axis, then we have to use relative distance. Otherwise we can assign the load on here. So in this here we're seeing that we have to assign load from the starting point to end point of that frame. So here to here. In these types of section we can easily provide load by using that point 0 and that point 1. That point relative distance here 0 and here 1. And in my previous video I have told you that Etabs always consider lower portion as a first portion. So this is the lower portion, it will be 0, absolute distance 0, and it will be relative distance 0 and it will be relative distance 1. And how is it we have calculated? You can see my previous video. I'm going to assign that. Here our direction are the opposite direction of local axis 2. So our relative distance, first when 0, then 0 when our distance, when relative distance on 1, then our loader how much, 1.5, and we'll make that 0. We'll make that 0 again, and we have to select a local axis 2. That would replace it. Sorry, we have to provide here minus because it's the opposite direction of local axis 2. Click here, apply. We have to select that object first. Select object, click here, replace existing load. What is that? Add to existing load. This means we have some load previously we have assigned, and we want to add some load with that. So then we have to click here and replace existing load. It means we have some load and we want to replace that. I mean the new load will be applied here and the previous load will be replaced with that. So apply here, and we're seeing that this is our uniformly varying load. And from here, this is uniformly distributed load. This is uniformly distributed load, so we can easily assign it. Select first of all, then frame distributed load, and then from here directly we'll first of all we have to select the axis. Here also it's opposite direction of local axis 2. I mean opposite direction of green axis. Then we'll just give here value and we'll make that all 0. We'll make it here all 0 and 0, here 0, and we'll give her the value. What is our value? 1.2 1.2, and it should be minus apply. Here is a load. We can apply that easily like that way, but the problem will be created, then close, when we'll apply load. We'll apply load from that point to that point. The question is how we'll apply load from that point to that point. And if we want to apply load from here to here, it's same as to 1.5 kLF. Suppose that I want to apply load in that full frame, so simply I have to go assign frame load, distributed load. We have to select relative distance as it is inclined, not in x or z direction. Then at 0 it's 0, and at 1 before that we have to see delete that, and on 1 then our load is suppose 5, make it 0 and also make it 0. It should be here also we are seeing that this is the opposite direction of green axis, I mean local axis 2. Then we have to select local axis 2 first, and obviously it should be minus, because when it is plus, if we apply we have provided that load in local axis 3. We have to delete that, delete existing load, and have to first have to select that local axis 2 and existing load. When 0 then 0, this is the 0 point, because the lower point will be always 0 and the upper point will be 1. Then apply. Here is the load 5 kilo load. So we'll delete that, select that, delete existing load, apply. Now the question is, if we want to apply load from that point to that point, I mean from here to here, from that point to that point, then how will assign that from that point to that point? So to assign that load, we have to calculate the distance from here to here. We have to, first of all, we have to calculate the full distance, then we have to calculate the distance from here to here. So first of all, we'll use consider this is a triangle. The down portion is 4 and here 5, 10, 8, 23. Now we'll calculate that angle. Click here. So shift, we know that tan inverse 23 divided by 4. Click up 80.1340 142 1342. So that distance of that is, sorry, the angle is here. We got our angle 80.31. Now we'll calculate that length. The angle is required for that angle because we'll consider from here. We know that height is 23 minus 5, 18, and we know the angle 80.13. So we know that height and we know that angle. So we can easily calculate that. Calculate that distance from here to here. So to calculate that distance, we have to use here, we know sine theta equal to height divided by that inclined portion. Let's set x. So x equal to a is divided by sine theta. So our height was 18. Our height was 18 divided by sine 80.134193. So here the distance of that point to that point is 18.27, and that point is, we can use Pythagoras equation, height square root over a square height square plus base square. So we'll get from here the value is 1 height (23) a square plus 4a square. 23.3452. So this is the value of total inclined 23.34524, and here the length of that is 18.27 and it's 23.34. So what is the length of that? Minus from that. So 23.34524 minus that 5.075. This is 5.075. So now we know that our first point is 5.075 and last point is 23.3452. Now we can use both system like absolute and relative. First of all, we apply absolute. Select that, assign frame load, distributed load, local axis to when our first point is 5, we'll select absolute distance. Absolute distance, first point is 5.075 and first point is that our load is 0 and when last point is 23.34524, then our load is, suppose load is 5, then apply. Here is your load. In this way we can provide our load at middle portion of a inclined frame. So I think it is okay, and if you think that again you have any problem about that or to understand about that, you can contact to me. Thank you very much. Stay connected.